Great to see everyone here today. I'm Levi Bowman. I work in data and AI at Solidigm. I think AI has been said too many times that I can't get it out. At Solidigm, we create world-class storage solutions, and storage solutions as in solid-state hard drives, not, nothing related to our rental project over here. I was lucky enough to work with an amazing amount of very smart people early in my career, and one of the lessons that we applied everywhere was asking a question of how hard will this be to undo? And sometimes people understand what I'm talking about, and in others they don't. So to clarify, when we talk about how hard it is to undo something, it's not we want to launch an AI agent and then we want to kill it next year. It's how hard is it to replace the database, the serialization algorithm, or some other component of a broader system that we're building and our team is responsible for running at scale and operating for the future. So now our case at Solidigm that we're exploring, building, and experimenting with is around our service desk. So we have thousands of tickets per month, and we're specifically targeting our level 1 function. So if we think about what level 1 does, it could be anything. Somebody could say, I can't connect to the network, I can't print, this system is down, this data is wrong in this report. The span of queries that come to our level 1 is enormous. So what we realized very quickly is that our data quality is not amazing. I don't think anyone's is. People start in ServiceNow, they end up in Teams, they go to email, and the data is spread all over the place. So trying to build a cohesive data set of what is happening in this space, what should we be doing, how do we build RPA and runbooks to solve all of this became an impossible problem. And that's only level 1 who solves a relatively small percentage of issues using Knowledge Bank or other pieces like that. So what this led us to determine is that really data quality is our problem in this space. It's too varied, it's too big. So our first experiment was to say, can we use an LLM with not really that much, but a decent amount of prompt engineering to build data quality? So before a ticket ever gets to a human, we use all the things that were talked about this morning, all the knowledge, all of the prediction of do we have enough data so that a human can actually go solve this problem? Because really our objectives and how we measure success here is the number of round trips back and forth. So if you're a caller, you come in and you say, my laptop's not working. And then 30 minutes later, somebody asks you a question to clarify because your data quality was poor. You didn't offer enough information in the beginning. Then the agent, who's a human today, has to come back and then follow up, and we get in this spiral of going back and forth, and we can have hours that go on. And before I mentioned that level 1 only solves a small percentage, so if we take that and then it gets to level 2 and we still haven't solved our data quality problem, we have this really long time. I think most people have experienced this. You open a ticket, you talk about it, it gets assigned to somebody else, and you have to talk about it some more. And from a user perspective, what is happening? And it's slow, data quality is not good. So our first step here is prompt engineering. And then we have a bunch of other requirements. So the second thing we had to add was tooling. And for us specifically, we need to open tickets in ServiceNow. We need to update them. The other thing we realized looking at historical data is, again, the LLM is pretty good at providing a description of what the issue is. And so from our experiments now, we have instant feedback or nearly instant feedback. If a user has a problem, it could be they can't access the system. We can create the ticket in ServiceNow for them. We can prompt them using LLM as a judge of is our data quality high enough to actually open the ticket, escalate it to a person. So we've shifted where our LLM is writing the description of all of these tickets via interaction with a user. And then the last thing that we have to do is we have to figure out where to route this to. So if somebody has a problem with a system internally, who's it going to go to? And we again came back to our data quality problem of our historical data. We have descriptions, often very terse. Our resolution information, not as complete as we would like it to be. The quality is just not there again. So we planned to use a traditional ML model based on historical data to figure out who to assign the ticket to, which person to assign this to next. What we've realized is more prompt engineering of what services are there. The technology that we can all use today is very good at going from my email doesn't work to we use Outlook to Office 365, and then we have a team that's responsible for that. So we've been able to move this very far forward. The other very interesting thing that we found is if you open a ticket and a human is servicing it, they're very likely to want to make a conclusion or tell you, and I think everyone experiences this, but if you interact with an agent Gen AI system, people are very open to providing feedback to it. So rather than just going in and saying, we're going to route this to this team, we're now asking the users, does this look right to you? This is what we think your problem is. Do you agree with this? And we keep the conversation instantly going with the user. And our early pieces show that our data quality is way better. Our users like it. And we certainly have the variety of users that say, I do not want to talk to AI. I want to talk to a person. I don't have a magic solution for that today. But we're working on it. So really what we're looking to accomplish here is reduce the round trips and routing accuracy and data quality. It all comes back to data quality for us. We have to build this repository of things that happen, runbooks, information that's needed to solve these issues for our users and solve them quickly and efficiently. So where we're building this is in Dataiku, and if we go back to my original question of how hard is this to undo, because I don't know about you guys, I heard a few minutes ago the question was asked, what do you think is going to happen next year? Honestly, I don't know what's going to happen next year. Is the pace of language models going to continue as it has been for the past 2? I'm not sure. So we have built this in a way with LLM Mesh and these other technologies where we can change models. We can use that data set to evaluate if our quality is still as good as it used to be. We can add tools, and we can continue to evaluate when our vector stores and our knowledge bank of how to solve certain problems gets updated. We can use that historical data to validate all those things too. So for us, the flexibility of being able to add and subtract components, tools, integrations as needed is very exciting. The next steps in the plans for us are really to add tools to this. So we get a lot of problems that say, my computer's not working well, or I can't access the system. Well, you need to be on VPN for that. So a tool that can, in real time, call an API and tell us if somebody's connected to the VPN is immensely valuable. And in how I really view this is we're stitching together all of these things that should have happened, but AI is what it really enables us to drive these things forward. So we're really excited to see how we can continue to roll out, build up our data quality, validate, and ultimately help our users at Solidigm have a better, more effective experience. Thank you.